Hey y'all, Data Guy here. And today I have a video for you where I wanted to go through an approach that I kind of came up with because of a use case I had for basically saying, hey, every time a certain number of batches or jobs have been generated in a Kafka queue, I want to trigger a Spark job that is going to retrain a machine learning model that I'm using for whatever purpose. In this case, it was customer support. Basically saying, hey, I want to take these new messages and this customer feedback, and I want to retrain the model and understand, hey, where are the biggest areas for customer growth? Where can we address issues that are coming up a lot over these different customers, and doing it in a nice weighted way. But really, this is a flow that'll work for any kind of incremental model update you want to do where, hey, I have some queue that's collecting inputs from whatever, input, data you want to collect from. User input is a really good one because, you never know when the users are going to actually generate, their inputs, right? And here it'll wait till it gets a certain size, a certain number of those messages in the Kafka queue. And then it'll take those with trigger Spark job, take those inputs, put them in a vector database for easier consumption by the machine learning model, and then trigger a model retraining on that new data to make sure that your model is always up to date with the latest information. So that's what we're going to go through today. Kick it over into the code. It's really going to be two scripts, one for my asynchronous Kafka monitor, and then a second one for the actual Spark job that we'll be triggering. So without further ado, let's get into it. All right, so the first thing we're going to do is import a whole different list of Python functions or Python packages. And so if you don't have these in your local environment, just make sure you download them or just pip install them into whatever environment you're using to run these. Here we're going to import OS first because OS is going to allow us to interact with the actual system, underlying system, save and propagate environment variables to there. JSON for interacting with JSON data, so making it easier to handle kind of the typical message, asynchronous message or that you would send over any kind of API. Async IO, this is the really critical library, and this is what's going to allow us to have an asynchronous process and not have this script be super heavyweight. This will allow us to basically have a process that's only going to be online and consuming compute resources when it's actually performing the monitor job, which will be for a very small amount of time relatively. We also have signal for generating signals, understanding whether something is active or not, logging for interacting and saving logs for better error handling, path lib because we're going to need to have a path to actually save something and move some data around. Date time and time delta for better handling of timing because that's going to be really good, important for our interval of how long we want to go between checks of the messages. Then we have list, dict, any. These are just for handling different types of data. Same thing for data classes. AIO files allows us to have asynchronous IO files. It also just makes it easier to have a file buffer. Then we also have PyArrow and Parquet. So we're going to store our data as Parquet files because that's one of the most efficient ways to store these files for AI purposes. And then for AIO Kafka, we're going to have an AIO Kafka consumer, top partition, and Kafka error. And this is from our asynchronous Kafka library, so you need both the async IO and the asynchronous Kafka library as well to allow Kafka to run in this asynchronous mode. And then we're also going to have an optional asynchronous Redis if you want to have state propagation. So first thing we'll do is just actually configure very basic logging, so just adding a logger here. And then what we can do is set up all of our different environment variables. So here's our configuration for our monitor, where we're going to have our Kafka Bootstrap servers, and I have an environment variable, but I also just have a default. So in production, use the environment variable, but here I'm just going to use a local variable so I can easily edit it between runs without having to go and change the actual underlying environment variable. Setting the training data to the topic, consumer group Spark, offset just latest, and we have our trigger thresholds here. So message threshold. So this is how many messages we want to wait to appear before we trigger the model retraining job. And then the time threshold of seconds is how long we want to wait between checks of how many messages have appeared within this queue. Then we have our staging settings. So these are just where we are going to drop our staging data, so intermediate staging area for us to use before we, as we're sending our data over to be used by Spark. Then we have our Spark job settings, so our Spark submit command, the Spark job that we're actually going to be submitting to the Spark cluster, Spark master, and which is just going to be the local host. It's been running Spark locally, the Spark deploy mode client, and then this is optional if you want to use Redis. You can add this for state persistence, and then for performance settings. So this is the max poll, so the max poll of records, the max poll time you want to accept, and then the consumer timeout as well. So when it'll time out if it doesn't get a heartbeat from the consumer back, and then health check as well. There's just a health check port on port 8080. So that is all just the basic configuration setup. So then what we'll do is set up a message buffer. And so essentially what this is going to do is basically allow us to have a buffer of messages that we're going to be collecting with all the metadata around that. And this is basically just going to be our staging area for our messages before we send them out to, to Spark, to our actual intermediary metadata location. So here we're just creating a list for messages, start time, offset, so we have a tracker of when we last collected these messages and we know how many messages to actually collect, and then a partition as well. And then here, add message to buffer, so just a function, just add a message to this memory buffer, get a get size, so this is how we're going to be querying this to actually understand how many messages are there and whether or not we should collect them and send them to Spark. Then age of buffer in seconds, how long it's been alive for, and been collecting data for. We'll also have a clear and reset, so after we collect that data, we can reset it to make sure we don't get duplicate data. And we also have a conversion function here for converting messages to records for the actual data frame creation. So that is our buffer all set up. So now the next thing we're going to need to set up is our actual asynchronous Kafka monitor. And so this is definitely the meat and potatoes of this entire setup here. So you'll see, go through it really nice and slowly. So here, starting off with just a Kafka, or a class for the async Kafka monitor, and then here we have the config. So in config, we want to set up, setting it to use our message buffer. We have our consumer, which is going to be AI, the Kafka consumer that we're going to set up asynchronously, our Redis, if you want that as well, defining running. So we have a flag for running. Is there a Spark job running? Is total messages processed right now, and also total Spark jobs triggered. So these are all just kind of helpful variables to have, so we know whether things have been triggered or not, and just keep that state consistent. And then we're also going to create a staging directory. So this is going to take the staging path we said earlier and use that to create a local staging directory. Then we have here an asynchronous Kafka consumer. So here we're basically setting a Kafka consumer up with that Kafka topic, bootstrap servers, all the different values we all set earlier. And then just making sure, hey, this Kafka consumer is actually started. And if you've configured Redis, here this will also start up a parallel Redis pool. But again, if you don't want to set up Redis or the state restore, you don't need to do this part. And then here we're storing the state from Redis if available. So this is just getting the jobs that were processed. And so this is really just a fancy way of having a kind of more robust storage between your runs. So in case something goes wrong, you have another record of the state that was actually left off at. So if something crashes, right, when the last update was, total messages processed, total Spark jobs triggered. But it's really just a couple of just quick collections of the state, just having one to load, initialize, and then save. Then down here, consume messages. So here's the actual main message consumption. So here we're adding messages to the buffer, so checking for any messages within the consumer, and then checking, hey, have we reached the amount of messages that we should have? If so, trigger the Spark job. Otherwise, we're just going to log the progress periodically to say how many messages are currently in the buffer. If there's any kind of interruption or cancellation, you'll see a message here raising exactly what caused that cancellation as well. So now the next step is going to define a quick check for should trigger. So if there's already a Spark job running, let's say, hey, get a ton of data. You want to make sure you don't double run. Check if job's already running. Check the message threshold, and then check the time threshold. And only if the buffer has messages should you then run. So the time threshold is essentially a backup where, hey, we're going to collect these messages no matter what every interval. Then we're going to trigger the Spark job with the saved data. So if the Spark job is running and the buffer size is in 0, then we're going to trigger the Spark job. So here we're going to set the batch ID of the current time, date time, the path for the config staging path that we defined earlier, and then the batch ID we're going to append there. Then we're going to make a directory there for that batch path. And then here we're going to stage those messages. So here we're going to use the stage messages function, which I'll show you in a few minutes. And then we're also going to build a Spark command to just send the Spark submit job with that stage file and that batch ID. then triggering that Spark job for that batch ID with the buffer, the amount of messages that you're actually consuming. So just another check. And then here we're going with async IO, create another process to actually trigger that Spark command. And then it's going to let it run in the background. So we actually aren't going to have a double monitor here. The asynchronous monitor is just going to, it's going to run in the background. And then whenever it's done, then the script is going to pick back up. And so here we're also going to commit the Kafka offsets after staging. So we have, hey, we've collected all these messages. Now any new messages, even though the Spark job is running, are also going to be collected and then processed in the next Spark job trigger. We're also going to clear that buffer, update the counter of the amount of Spark jobs that have been triggered, and then just save that state as well. And then here we are then going to define another function, so that's stage messages function. So asynchronous function here for staging messages to that file system for Spark processing. So here the staging format, again, setting it as Parquet. So this is where stages Parquet is going to be, or JSON. So whether you want to switch it out. So here I'm going to use Parquet, but wanted to also show you that, hey, you can have multiple different file types, and you just want to have functions that'll handle, hey, what type you want to save this as. But this one's definitely a little bit more use case dependent. And then, so stages Parquet, since this is our default, right, we're going to be saving this to that batch path that we defined earlier with that unique ID, data.parquet. So within that path, it's just all these files are going to look the same as data Parquet, but they're going to be within folders that have that designating information. And then we're going to convert those messages to arrow tables. So here to data frame from those records from just a raw list into an actual arrow data frame. And then here we're going to define the schema. So timestamp, ID, features, label, metadata, create a table, and then write to Parquet. So this is going to write this to a Parquet file. And then here we're going to just run an executor. So just use the asynchronous IO file operations for actually writing this. And then return the file path where we stage, hey, X number of messages to this given file path. Alternatively, if you want to save it as JSON, right? If you want something a little simpler, you don't want to use Parquet, you can just say, hey, just save this in, JSON dump style, right? With JSON.dumps, and this is just, very typical. Also, if you just wanted to save a CSV, really any other file path, you can use that here. Then we're going to build the Spark submit command. So here we're going to build a Spark command. So you can use Spark submit command, master, and then a lot of these are just pulling in those values we set earlier. So the job path, the stage path, batch ID, the message count, and then the deploy mode as well. And then the only two ones are just, hey, we're going to have an adaptive mode and coalesce partitions if needed. And then this is going to return the joined command. And then here we have a Spark job execution monitor as well. So this is where we're going to have a monitor that says, hey, has this Spark job actually been completed? And again, another asynchronous definition here, so this can run in asynchronous mode and ping regularly and say, hey, how long has this job completed yet? Once this job is completed, resume the rest of the script. And then here, cleaning up stage files as well. So cleaning up all the stage files after successful processing. You can take this or leave this, right? If you want to save that raw data, you can, but you don't necessarily have to. So I wanted to show you how to do this. And then you also have a saved batch information for manual retry. So if something fails, you also have a saving function here for retries. And then also committing offsets. So, hey, commit your Kafka offsets to make sure, hey, you're tracking that we've collected this set of data and now move on to the next chunk. And then also we have our periodic check for time-based triggers. So this is another crux of the whole script. So, this trigger is being used for triggering the Spark job and then also for monitoring it after. So here, what it's going to do is check, hey, every 30 seconds, check if it should trigger a Spark job. And this is what is going to then go through and do all those checks, make sure, hey, have there been 1,000 messages? How's it reached that 300-second mark? If so, then I'm going to trigger a Spark job. So just a couple lines here. This is really where the async sleep IO gets implemented, and the rest of the script is dependent on. And then I just also added a fun little health check server here as well. So if you want to have, because this is meant to be a long-running application, you're running in Docker somewhere, there's also an endpoint for getting a quick health point check as well. And then down here, we have the main run loop. So asynchronous run def here. So while running is true, this is going to initialize the resources and then create concurrent tasks of consume messages, the trigger, and the health check of the server. These are then all going to be running for, essentially until you tell it to shut down, and you have a canceled error, and then it's going to shut down. And there's also a graceful shutdown here as well, where if you explicitly run the shutdown command, this will trigger process for any remaining messages, and then after that, close all the connections and then fully shut down. So then, just to finally implement that, what we can do here is, sorry, let me fix that. Go and just finally implement a asynchronous class to actually define this monitor. So here we have monitor config, the main entry point. Then we're starting it up with all these different configuration details we said earlier. Starting that asynchronous Kafka monitor class. That was that massive script we just went through. And then we're just setting up those signal handlers here for graceful shutdown as well. So if you receive a graceful shutdown, then do that. Otherwise, it's just going to kill it in that less graceful way. And then also just defining a asynchronous run. So when the script is run, just start all these processes. So that is the Kafka side of things. Really is, I'd say, the more interesting side of this, because it's showing you, hey, you can have an asynchronous monitor of a Kafka queue that will then go trigger a Spark job to run and do that heavy processing only when it's actually needed. But on its own, this script is going to take up very, very little computing power. So now we'll move on to our Spark job. And so here we'll have a lot of the same imports. So I won't go through the ones that we've already talked about, but the new ones start down here. So we have the PySpark SQL, so creating a Spark session, data frame, different functions for columns, unique data functions, lits, current timestamps, array type and double type for data types, NumPy as NP. We're also importing joblib and some different just kind of standard open source sklearn machine learning packages to just show you, how we'll be doing this machine learning, and also a vector DB import as well, where you can see we're just importing everything for Weaviate. So we'll be using Weaviate as our vector database, just really, easy to use open source option here. And then next what we'll do is start setting up our logging again, as we did in our Kafka script, and begin defining our Spark training job. So here we're just initializing a class Spark training job for incremental model training and vector DB updates. So here we are initializing Spark, arguments that we'll pass in, the model path, so we'll have a model path for models on wherever you're storing your models, and then you could also sub this out, right, if you're using an external model catalog, vector DB type, MILVUS. So actually, to make a quick edit there, I caught a little fragment from an earlier version of this. So we're using Weaviate, so you don't need to add that PyMilVus, just add this Weaviate embedded and embedded options. This will handle the embeddings. And then for the Spark session, so model path, everything there is the same. And then we're not going to have that thing for setting up PyMilVus here. So have our Weaviate client, which is going to default to none because we're going to add that in a second. And then here for run, we're first going to initialize the Weaviate connection for our vector database, load stage data. We're going to then do some data validation and pre-processing, then generate embeddings, store those in Weaviate, perform some incremental model training, save those metrics, and then do a cleanup. And then here we're just having some logging and exceptions as well. And then so now let's go through and build all those individual functions. So here we're just going to use embedded Weaviate, and then so this means basically, hey, am I going to use a local embedded Weaviate instance, or you can connect to a external Weaviate instance if you'd like that as well. But here we're just going to use a local one. So localhost 8080 for external Weaviate instance, and then our API key as well, and the client as well for that if you're using a hosted Weaviate. And then otherwise, it'll throw an exception there. And then once that Weaviate schema has been verified to exist, so here we're going to make sure, hey, Weaviate class, training embedding, we're going to check if that class exists within Weaviate, so a embedding for our training data. If it doesn't exist, we're going to create it. So this is something where if you haven't, probably would just want to do this ahead of time instead of doing it as part of the script. But here we're defining a schema for those training embeddings. So vectorizer, we're going to provide our own vectors. We don't need that. And then here, properties, the record ID is the main the ID for processing, batch ID are the features, so the actual information from the data, the label, any training label we're going to assign, the metadata, and a process stat timestamp. And then our vector index is just going to be, cosine, EF 200, EF construction, and this is basically just setting different values for how our vector indexes are going to be generated, but you can just leave these as defaults. That's what I did. And then here we just have created VV class, otherwise it'll throw an error as well. Then we have a function for loading our stage data, so getting that input path we defined earlier. If it's with Parquet, getting it from the Parquet location. If it's not, getting it from that JSON location. And then if it's under supported file format, it doesn't detect a Parquet or JSON file there, it'll throw an error. Then it's going to run a .count on the data frame there. So it's reading whatever type it is, it's going to read it in as a data frame, and then add any batch metadata. So the batch ID, process.timestamp, and then return a data frame from there. Then it's going to pre-process the data, so it's going to take out any null value, any null records, making sure features are properly typed, so array, making sure, hey, we're going to convert the features to the proper types we need. So this is where you change it to whatever type you actually want, and then you have converting to back into a data frame now that everything has the proper data type of that double type. And then creating a cache for multiple operations. If you need a cache, you can have that as well. Do that in parallel. And then here we're going to return that data frame. Then update that vector database with those embeddings. So processing in batches. So 100 each for each 100. Just processing those into our Weaviate database. And so here you can see for I in range, this is just then going to go through and process all of those vector data, all those pieces of data, and store them as vectors within Weaviate. Then we're going to go down here, and we're going to store a batch of embeddings in Weaviate. So just store in Weaviate, which is then going to have a second function, class name, which is getting that training embedding, so that location within Weaviate, that schema, and then generating the embeddings if needed, which is calling that embedding function we just went through, and then doing a batch insert into Weaviate with those vectorized embeddings. So here, adding to batch with vector, adding those data objects after we prepare the properties, and then again configuring the batch sizing for how we want to batch ingest them into Weaviate. And then here we have generated embeddings. So this is where we're actually going to be generating those embeddings. So just do we want to generate them or use the raw features? We are going to generate them. And then from the sentence transformer, since we're dealing with text data, this is then going to use this sentence transformer and this embedding model here to then take our feature or our text features and convert them into vectors. So here we're creating text representation of those features, appending them to this text data frame, and then encoding them. So here, making sure, hey, we take out all the empty spaces, generating those embeddings, and then returning those embeddings to a list. And then that's the list that actually is going to get updated into Weaviate. And then after that data is updated and sent up into Weaviate, then we're going to train the model. So here we're going to perform that incremental model training. So here, checking if we have labels for unsupervised training. If it has labels, train supervised. Otherwise, train unsupervised. Then it's going to train that supervised model incrementally. So this is obviously where you swap this out for however you're doing your model training. So collecting all those features, going through my features and their labels, splitting them up into features and labels. Then loading or creating a model, whether or not you've already created this or this is the first run. So here trying to load that existing model. If it doesn't exist, then it's going to create a new model. So check if it's regression, classification, and this is where it just shows some random fun models to use. So the HTC classifier and regressor here, if it's classification or regression. Then doing some scaling of those features to make sure outliers don't affect the model too much, doing a quick fit of those features, and then training the model incrementally. So here, calculating all those metrics, just doing classic, partial fitting of those scaled X values, calculating those metrics, and then every time this runs, this is then going to do, additional partial fit of those new X values that we're going to update. So here, then we're going to, this is for classification, same thing for regression. So then we're going to save that updated model, save a versioned model as well, and then, just put out in the logs, hey, we've saved and updated this model. And then alternatively, you have another option for training an unsupervised model where you're collecting all the features, loading it up, and then trying to train unsupervised and, k-means or incremental PCA. This is just another type of model training. Then we're just going to save the results. So whatever type of model you did, we're going to save those training metrics and results, save them to a file, and then if we're using MLflow, do something like saving them to MLflow here. So save metrics to MLflow if it's available. If you're using MLflow, this is kind of how you would do this here, right? Is just setting a tracking URI, saving that model. But I'm personally not. I just want to show you how to do it. And then finally, down here, cleaning up all your stage data. So making sure you're cleaning up any stage data file so you don't basically duplicate the data and have it generated twice every time you run this model. And then all we need to do to wrap up this setup is couple more functions down here. It's the classic create Spark function. So here's Spark Session Builder with all those config values and the app name that we set earlier. Then we have main entry point. So here Spark job for passing in the input path, so the actual files. This is what from our Kafka script. Remember, we're sending over the input path, the batch ID, the message count when we're actually triggering this. So this is what's allowing us to do that. And then we just have some loggers for starting what kind of model training we started, creating the Spark session, running the training job, and then just setting stop when the job is complete. So that is everything I have for you today. I know there's a lot, but I hope you enjoyed this video. I hope you found it helpful. I hope you have a great rest of your day. Data Guy out.